Okay, number 7a, how many x-intercepts are there? We say 4. Let's see, we have one here at -5, one here at -1, one here at 0, and one at +4. So -5, -1, 0, and 4. So I agree, there are 4 x-intercepts. Part B, what is the lowest possible degree? You might think it's 4, but I believe it's 5. And here's why. It has to do with this root behavior and how the graph is behaving right there. At that location, at that x-intercept of -5, it's acting kind of like a parabola. See how it opens up like that? And it bounces off the axis right there. When that happens, we have what's called a double root. We have a double root at -5. So you have to count that as if it's 2 x's. So when you're counting up the number of intercepts to determine the number of degrees, that counts as 2. The other 3 at -2, 0, and +4, it looks like they're just single roots, the way that it's slicing through. Yes. So if this graph was shifted up a little bit and it went like this right there, it would be another double root there, and there would only be 3 x-intercepts. Yes. Let's say that when it bounces off the axis and doesn't cut through, or it just touches the axis, that's known as a double root. So again, the lowest possible degree of this function is actually 5 because there is a single root here. That's 1, 2, 3, and this counts for 2. So the lowest possible degree is 5. So here's what happens when you go to write out the equation. Hopefully you're familiar with this format. A times x minus root 1, x minus root 2, x minus root 3. Can I put a dot, dot, dot? That means the pattern continues, and it just goes up until however many roots you have, however many intercepts. So when you're going to write out the 4 intercepts here, one of them needs to be squared, and it's because of that double root. So are you ready? Let's go ahead and do x. What would x minus -5 look like? X plus 5. We're going to revisit this in a moment. Times x minus -1 plus 1. Then you're going to have x minus 0, which is really just x. Okay? And then x minus 4 represents the 4th x-intercept. -4 because it's at +4. So that doesn't indicate that we have a degree of 5, because how many x's do you actually see here? 4. So one of them needs to be squared. It's the one that acted like a parabola. So at x plus 5, it's squared. That's what causes that behavior. So now that we've established that there's a double root at -5, therefore we have the x plus 5 squared, we still need to find the dilation a. And to do that, we can't use 0, 0 this time, because if we used 0, 0, which is our y-intercept, it would look like this, and it would be, do they still call things fails? It would be a fail. You still say that? Okay, it would fail. Watch, because what would happen here? What would this entire equation say? It would say 0 equals 0, and that does not help you find a. The zeros would kind of cancel the whole thing out, and it would be a fail. So instead, when that happens, what you want to do is you want to look for another point on the graph that you can use. And luckily, they gave us a point right there. They're telling us that 1, 216 is on the graph. So that means when y is 216, x is 1. It's a little bit more work than using the y-intercept, because instead of zeros, you have 1s in there. a little bit more involved, but I believe you can do 1 plus 5, right? I know you can. What's 1 plus 5? 6 squared is 36. Here we have 1 plus 1. 2. Then we have a 1. Then we have a 1 minus 4, which is negative 3. Go ahead and multiply these four numbers for me. Which is negative 216, A. When you divide by negative 216, what's A? Negative 1. Okay? Now, what I want to relate to you in the next video, in the next segment, is that when A is negative like this, so it's y equals negative 1 times x plus 5 squared times x plus 1 times x minus 4. That's a pretty involved equation. But when the degree is 5 in this, right? The degree was 5, and A was negative. Look at the general nature of this graph. How does it behave at the beginning? In a downward fashion. It does some funky stuff in the middle, but ultimately, how does it end up? In a downward fashion as well. Remember that. The degree was odd, 5, and A is negative. It starts downward, finishes downward. More on that in the next video.